Hello everyone. Today I will discuss about linear differential equation. Linear differential equations. A differential equation is said to be linear when the dependent variable and its derivatives appear only in the first degree and not as higher powers or products. The general linear equation of first order can be written in the form dy by dx plus py is equal to q, where p and q are functions of x or constants. If p and q are both constants, then the variables are separable. If either p or q is 0, then it is also separable. कोई सा भी डिफरेंशियल इक्वेशन जिसका फॉर्म dy बाई डी एक्स प्लस पी वाई इक्वल टू क्यू हो, जहाँ पे p और q x का फंक्शन है या तो कांस्टेंट है, तब इस तरह का इक्वेशन को हम कहते हैं लीनियर डिफरेंशियल इक्वेशन। अगर p और q दोनों कांस्टेंट होता है तब वेरिएबल्स आर सेपरेबल। अगर p और q 0 होता है तो भी ये इक्वेशन सेपरेशन ऑफ वेरिएबल होता है, सेपरेबल वेरिएबल होता है। केस 1, सपोज q is equal to 0, p is non-zero, then we have from equation number 1 dy by dx plus py equal to 0 implies that dy by y is equal to minus p dx. By integration we get log of y is equal to integration of p dx plus log of c, and which gives y is equal to c e to the power minus p dx, where p is the coefficient of y and the right hand side q is equal to 0. In this case, c is arbitrary constant of integration. Case 2. Suppose that p is equal to 0, q not equal to 0. Then we have dy by dx is equal to q, which implies that dy is equal to q dx. And after integration we have y is equal to c plus integration of q dx. Case 3. Suppose that p is equal to 0 and q is equal to 0. Then we have dy by dx equal to 0, which gives dy is equal to 0. अगर p is equal to 0, q is equal to 0 होता है तो dy by dx equal to 0, which gives dy equal to 0. After integration it gives y is equal to c. Case number 4. Suppose that P not equal to 0, Q not equal to 0. Multiply both sides of equation number 1 by e to the power integration of P dx. Then we have e to the power integration P dx into dy by dx plus Py e to the power integration P dx equal to Q e to the power integration P dx, which implies that e to the power P dx into dy by dx plus y into dy dx of e to the power integration P dx equal to Q e to the power integration of P dx. Implies that dy dx of y into e to the power integration of P dx equal to Q e to the power integration P dx. Therefore, after integration, we have y e to the power P dx, y e to the power integration of P dx is equal to integration of Q e to the power integration of P dx plus C, which gives the required solution. The quantity e to the power integration of P dx is called the integrating factor or IF of the given differential equation. Therefore, the general solution is given by y into integrating factor is equal to integration of Q into integrating factor into d of dx plus C. Now solve example 1. Solve dy by dx plus xy is equal to x cube. Comparing the given equation, this dy by dx plus xy equal to x cube with the standard linear differential equation dy by dx plus py is equal to cube, we have here coefficient of y is equal to x, here coefficient of y is equal to p. Therefore, p is equal to y, and similarly q is equal to x cube. So, by comparing, we have p is equal to x, q is equal to x cube. Therefore, the integrating factor IF is equal to e raised to the power integration of p dx is equal to e raised to the power integration of x dx, because p is equal to x is equal to e raised to the power x square by 2. Therefore, the general solution is given by y into integrating factor is equal to integration of q into integrating factor into dx plus c. Which implies that y into e raised to the power x square by 2 equal to integration of x cube into e raised to the power x square by 2 into dx plus c. Let to solve the above equation, let x square by 2 is equal to z, then x dx is equal to dz. Therefore, integration of x cube into e raised to the power x square by 2 dx is equal to integration of x square e raised to the power x square by 2x dx, which is equal to integration 2iz e raised to the power z dz. Equal to 2 into z e raised to the power z minus e raised to the power z, equal to 2 into z minus 1 e raised to the power z, equal to 2 into x square by 2 minus 1, क्योंकि z is equal to x square by 2 है, x square by 2 is equal to z. By substituting this value in place of z, we have 2 into x square by 2 minus 1 e raised to the power x square by 2. Therefore, from equation 1 we have y into e raised to the power x square by 2 is equal to 2 times x square by 2 minus 1 into e raised to the power x square by 2, because this integration is equal to this value. Therefore, the required solution is y into e raised to the power x square by 2 equal to 2 into x square by 2 minus 1 into e raised to the power x square by 2 plus c. Example 2. Solve y square plus x minus 1 by y into dy by dx equal to 0. Solution. Since the given equation contains y square, so it is not linear in y. ये गिवन इक्वेशन में ये जो y स्क्वायर का टर्म है, इसलिए ये इक्वेशन लीनियर नहीं है, क्योंकि हम जानते हैं कोई सा भी लीनियर डिफरेंशियल इक्वेशन में डिपेंडेंट वेरिएबल का पावर एक से ज़्यादा नहीं होना चाहिए, एक्सपोनेंट एक से ज़्यादा नहीं होगा। यहाँ क्योंकि इसका एक्सपोनेंट 2 है, इसलिए ये इक्वेशन y पे लीनियर नहीं हो सकता। Therefore, we can rewrite the given equation in the form dx by dy is equal to 1 by y square into 1 by y minus x, which gives dx by dy plus 1 by y square into x is equal to 1 by y cube, which is linear in x. The above equation is linear in x. So, therefore, integrating factor is equal to e raised to the power integration of integrating factor is equal to e raised to the power integration of p dy equal to e raised to the power integration of 1 by y square dy is equal to e raised to the power minus 1 by y. Therefore, the general solution is x into integrating factor is equal to integration of q into integrating factor dy plus c. Implies that x into integrating factor e raised to the power minus 1 by y is equal to q is equal to 1 by y cube into integrating factor e raised to the power minus 1 by y to dy plus c. To solve the above equation, let 1 by y is equal to u. So, minus 1 by y square dy equal to du. Therefore, integration 1 by y cube into e raised to the power minus 1 by y dy equal to integration 1 by y 1 by y square into e raised to the power minus 1 by y dy equal to minus integration u e raised to the power minus u du, which is equal to u e raised to the power minus u minus integration e raised to the power minus u du by integration of by parts, which is equal to u e raised to the power minus u plus e raised to the power minus u equal to u plus 1 e raised to the power minus u equal to 1 by y plus 1 into e raised to the power minus 1 by y by substituting the value of u. Therefore, the general solution is x into e raised to the power minus 1 by y is equal to 1 by y plus 1 into e raised to the power minus 1 by y plus c, or by simplification x is equal to 1 plus 1 by y plus c into e raised to the power minus 1 by y. Thank you very much for watching this video, and please don't forget to subscribe my channel.